Hi there. This video is an exam paper walkthrough of the Edexcel GCSE Mathematics Higher Tier Paper 2 from summer 2023. This paper is worth 80 marks in total, and this is the second video of 4. It will focus on questions 7 to 12, which account for 21 of these marks. Edexcel Paper 2s are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 7. A number D is rounded to one decimal place. The result is 12.7. Complete the error interval for D. So this is the error interval, so we're looking for a lower bound and an upper bound. If we've rounded to one decimal place is in the tenths column. So one decimal place is to the nearest 0.1. Half of 0.1 is 0.05. So for the lower bound, we do 12.7 subtract 0.05. Which is 12.65, and then for the upper bound we do 12.7 add 0.05, which is 12.75. Question 8. Tamsin buys a house with a value of 150,000. The value of Tamsin's house increases by 4% each year. Rachel buys a house with a value of £160,000 and the value of Rachel's house increases by 1.5% each year. At the end of 2 years, whose house has the greater value? You must show how you get your answer. So if we're increasing by the same amount each year, we're going to do compound interest for 2 years. So let's start with Tamsin. So Tamsin started with a house value of £150,000, but it increases by 4% each year. 4% is 0.04 as a multiplier, but if we've increased by 4%, we're wanting 104%, wanting the original plus that 4%. So our multiplier is going to be 1.04 and to the power of 2 for 2 years. So let's pop that in our calculator. So that's £163,240 at the end of 2 years for Tamsin. Let's do the same for Rachel. So Rachel's was £160,000, increasing by 1.5%. So 1.5% is 0.015. So 101.5%, because it's that increase, is equal to 1.015. So 1.015, still to the power of 2 years. Is 164,836. Whose house has the greater value? Well, Rachel's has the greater value, so you can write Rachel's nice and clearly for them to see. Question 9. The cumulative frequency table gives information about the ages of 80 people working for a company. So this is our cumulative frequency table, and we'd expect 80 to be the last value because they've been added up as they go. On the grid opposite, draw a cumulative frequency graph for this information. So here's the grid that we need to use to draw this cumulative frequency graph. This is the table we're going to use. So with the cumulative frequency graph, you need to use the end point plotted against the cumulative frequency. So for this first one, we're going to go across to 30, up to 20, across to 40, up to wherever 48 is. Be careful with your scale so you know how much it's going up in. I know that each of these smaller squares is worth 1 because there are 10 between these two values here. And then we're going to 50 and up to 64, 60 and up to 75, and then 70 and up to 80. I'd recommend that you do this in pencil just in case you make a mistake, but now we need to simply draw a smooth curve through those points. It doesn't have to go from 0, but you can join it to 0 if you want to. Just needs to be a rough, smooth curve. So that's part A. Part B, use your graph to find an estimate for the median age. So the median, remember, is the middle. So we want the middle age. So we've got 80 people in total. 80 divided by 2 is 40. So the middle age should be when we have a cumulative frequency of 40. So we're going to take 40 in our cumulative frequency, read across to our graph, and then read down. And then we're going to estimate this value here. From 30 to 40 is 10. So I think that's 36. So an estimate for the median age would be 36. Question 10. A biased dice is thrown 60 times. The table shows information about the number that the dice lands on each time. So we've got the number on the dice and the number of times that it lands on this number. Gethin throws the dice twice. Part A, work out an estimate for the probability that the dice will land on 6 both times. So the first thing we need to do is find the relative frequency that the dice is going to land on a 6. So if it's thrown 60 times, 15 of those times it landed on a 6. So it would be 15 out of 60 for the relative frequency. And if we want it to land on a 6 both times, then we would multiply that frequency together. So 15 over 60 multiplied by 15 over 60 is equal to 1 over 16. So we're going to stick that on our answer line. Sally is going to throw the same dice n times and record the number it lands on each time. She will use her results to work out a more reliable estimate for the probability in part A. What can you say about the value of n? So if we want a more reliable estimate, then the value of n, so the number of times that they throw the dice, needs to be more than 60, because the more times we carry out an experiment, the more accurate our results are. So n must be greater than 60. Question 11. Use algebra to solve the simultaneous equations that we have there. So I'm going to make the y terms the same so I can eliminate y. So I'm going to multiply this equation by 4 and I'm going to multiply this one by 6. So I've multiplied each equation by the coefficient of the y in the other equation. So 2x times 4 is 8x, 6y times 4 is 24y, and 5 times 4 is 20. Remember, at any point you can use your calculator here. 3x times 6 is 18x. 4y times 6 is 24y, but it's a negative. And then negative 12 times 6 is negative 72. Again, you can use your calculator at any point there, guys, because it's a calculator paper. Especially if you're dealing with that negative calculation, just to make sure you get the correct sign in your answer. Now that the y terms have the same coefficient, I'm going to look at the sign in front. The sign in front is different, so to eliminate the y, I need to add these two equations together. So 18x add 8x is 26x. The 24y subtract the 24y because it's 24y plus negative 24y. It's going to cancel that out. And then 20 plus negative 72 is negative 52. Now I'm going to divide both sides by 26. So negative 52 divided by 26 is negative 2. So I'm going to pop my x value there on the answer line. Now I know my x value, I'm going to substitute it back into one of these equations to find y. So I'm just going to use this first equation. So 2x add 6y equals 5. If x is negative 2, that's 2 times negative 2. 2 times negative 2 is negative 4. So now it's a case of solving for y. So I'm going to add 4 to both sides. Then I'm going to divide by 6. Now if I put 9 over 6 in my calculator, I can convert it into decimal form. You could write 9 over 6 on your answer line though, it's equivalent, but it's also equal to 1.5. So I'm going to put 1.5 on my answer line. Question 12. The points A, B, C and D lie on a circle with centre O. A, B, C, D is a rectangle. So we have this circle with centre O and then we have a rectangle here, A, B, C, D. AB is 8 centimetres. They've already put that on the diagram for us. BC is 10 centimetres. Work out the circumference of the circle. Give your answer correct to 3 significant figures. So circumference is pi times diameter. We don't know the diameter of the circle, we need to work it out. The diameter of the circle goes from one edge of the circle to the, so one area of the circumference, well, start again, one side to the other and it goes through the centre. So if I draw that diameter on here, we can see that it's actually the diagonal of the rectangle. So if we use the information for the rectangle to find the length of the diagonal, we can then find the circumference because that is also the diameter. So what we'll notice is a rectangle has right angles. So here, regardless of which triangle we choose to use, we will have a right angle triangle. So let's go with this one. So I know that this length is 10 centimetres. I know that DC must be 8 centimetres because it's a rectangle and that's the properties of a rectangle. So now I can use Pythagoras to find this length here, DB. So the length DB squared, or the diameter squared, is equal to 10 squared plus 8 squared. So 10 squared plus 8 squared is equal to 164. But I only want the diameter itself, so I'm going to square root that. So the diameter is 12.8. I'm going to leave it there for that one. So this is the diameter. Now we can work out the circumference. So the circumference equals pi times the diameter. I've actually left it in my calculator. So even though I've rounded it here, it's staying quite accurate here. So I'm multiplying by pi. So the circumference is 40.23201613. Now it wants our answer to 3 significant figures. 1, 2, 3. That 3 doesn't change the 2. So the circumference to 3 significant figures is 40.2 centimetres.